The first few designs we tried decreased the distance the straw went compared to the initial power and angle tests that used straws with just the front end taped. These designs included a paper plane, weighting multiple places on the straw such as the front and middle, and the front end a quarter of the way down from the front, a rocket, and a nose cone. After these more complex designs did not work, we decided to go back to simpler straw designs like the one that was used in the initial power and angle test. We started by adding a small ball of paper to the front of the straws so that the front of the straws would be weighted. Then we cut those straws shorter so that the air pushed out by the launcher would not have as far of a distance to travel before reaching the end of the straw, and so that the straws would be lighter. 2 layers of tape were added to some of the straws because one straw that was taped with extra tape had been going further than the other straws. Once we had multiple straws that had one ball of paper in the tip with either 1 or 2 layers of tape and cut down to short and medium lengths, we launched those straws at the same power and angle, then eliminated the straws that went the shortest distances until the best straw was chosen.
Here is the data we were able to collect over the 3 days we spent shooting our straws. We initially tried to be unique and creative with our ideas, shooting a straw with wings and high hopes, but that failed miserably. The launcher didn't generate enough force to make the wings effective, and as a result, the plane stalled and fell down after only a meter. After a day or so of trial and error, we found that the best rocket was one that was weighted on the end moderately with no other attachments. It's a minimalist approach, but so far it's worked well. The smooth, sleek design and light design makes the surface area minimal, and the low weight all helps to decrease air resistance as much as possible. After finding the right design to maximize distance, we worked with various angles between 30 and 45 degrees to see which works best. 45 degrees should theoretically be the best angle to launch from because the horizontal and vertical velocities are divided equally, but in this actual setting, the straw is more susceptible to wind. As a result, we found that the best results come from 45 degrees on a day with no wind and around 35 to 40 degrees on a day with wind, as this makes the projectile stay closer to the ground and more sheltered from the possible.
This is the straw we came up with. It is cut to a length of 15.5 centimeters, it has a ball of paper in the tip, and there are 2 layers of tape around the end.
This straw will travel the furthest due to its effective design. The extra tape and paper ball give the nose end of the straw extra stability in flight while still being light enough for the air launcher to lift. A stabilized straw will fly straight, rather than veer to one side or another. The straw has also been cut short, making it lighter and easier to propel. However, the straw is not too short and will still fly straight as a projectile.